the NX students, there is a practical midterm on Wednesday. For the CATIA students, there's a practical midterm on Friday. And our written midterm is a week from today. There have been a few of you that have emailed me, both here at BYU and remote students, asking what the format of these tests are going to look like. Let's start first with the practical. The format of the practical is you'll show up in lab. You'll have an hour and 50 minutes to complete a number of exercises that will be similar in nature to the exercises that we have done in lab. Realizing that the team center engineering thing that we attempted to do kind of backfired and didn't come off. So we're not going to have any team center. There's not going to be really much collaboration because it's an individual exercise. So it's going to basically lock in on things like top-down skeletal assemblies. It will lock into things like hyper mesh and OptiStruct. It'll lock in on those types of lab exercises that you've been working on and doing. Okay?
So the hour and 50-minute time limit will be considered in the amount of things we're going to do?
Yes.
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 Because usually one of those processes takes about half.
So we are basically working to come up with something that is doable in the hour and 50 minutes. So it's not intended to be necessarily start from scratch and do everything. Okay? It's basically take this and do stuff on it. Okay?
Well, never mind.
I think you were kind of answering it there, but as far as like say the hypermesh, when I go through and do any optimization, I have the lab out and I'm following steps. Like, I mean, do you expect us to kind of like know everything, like how it all comes to play, or is it just going to be like? Is it that?
So you're asking whether it's open book or closed book, or can I go to help files and can I do those
I mean, are
kinds
you
of
expecting
things?
us to understand each component in that lab? Say, you know, where are the D constraints? Where is that? All that? You know what I mean?
Yeah, that's exactly what we're talking about. It's the same guy. Come on, guys.
So if I don't answer your question, ask it again. It is going to be open note, it's going to be open lab, it's going to be open help files, it's going to be whatever you have as a resource that is yours or distributed by the software company. Go for it. Okay, that's going to be yours to reference and use and work with and everything else. Is that?
Yes.
Okay.
I'd rather.
So, in the way of preparation for that, would you say like going through the labs and just refreshing what we've done?
Making sure that you can do the labs in a reasonable amount of time and that you don't get hung up on one thing and go, I don't have a clue as to what this thing is doing. Making sure that you understand the steps of the labs would be a good thing. Yes.
Last one is this lab this week going to be on there as well?
This week you're doing the fancy car stuff, right?
Yes.
The surface modeling stuff. Would you like it on there?
No. That takes so much time.
So much time, but it's fun stuff,
No,
right?
It's
fun.
It is fun.
It is fun. You know, I look back on all of the semesters and the students tend, once they kind of get a car there that they've done, they go back and say, this was the funnest thing, was just modeling up, cool looking stuff. So it will not be on there. Is that right, Clarissa?
What's that?
Surface modeling, we've not put that on
On the midterm?
the midterm.
No.
It's not on there unless you really want me to put it on there.
That was also the lab before that was also surface modeling, simple surface modeling.
So simple surface modeling is fair game. But the kind of stuff that we did in the second model is not gonna be there. So. Other questions on the practical? Yes?
Since we're having the practical exam and lab, we're not gonna have design reviews, is that correct?
So we will not have design reviews. We will give you the entire period. So we will not have design reviews next week. That's a good point. So, other questions? Okay, so let's shift to the written, which is a week from today. The written midterm will be in this class for the BYU students. So it'll take 50 minutes. For the remote students that can do it during this same period, we would ask that you do it. There are some students, however, that will be listening to this tomorrow when they wake up. For those students, they will just need to choose a 50-minute period of time on Friday and take their exams and get them back to their instructor, their local professor, and turned in. So we will have 50 minutes to take it. It will be an open book, open note test, but students that have taken classes from me and I've heard rumors that my written exams tend to be a speed writing experience. It's not going to give you a ton of time to go and read a chapter and figure out an answer. I mean, maybe you can read a chapter and figure out a answer, but not do very well on the exam. So it's intended to be work as much as you can through the exam, doing the things that you know to do, and then if you have a problem you're stuck on, go to your material, look at it, reference it, try and get unstuck and move forward. So I would work everything that you can possibly work, get it done, get it set aside, and then work on the things that you're unsure of, okay? Do not think that it's going to be set up in such a way that you can basically go through your book hunting for answers to be written on the test. What is it going to cover? It's going to cover everything that we have lectured on since day one. Is fair game for the test. Okay? It will tend to be some short answers mixed with some short essays, half a paragraph to a paragraph type answer. And there may well be some curve mathematics and or surface mathematics that you will find on the exam.
I know with some of the lectures you referenced outside PDFs, like the one I'm thinking of in particular is with the hypermeshing and the optimization. Are you going to go into those materials as well, or do you just?
Yes, yes. So anything that we've handed out and kind of said this is supplemental reading, it's fair game, is the mathematics of optimization, topology optimization on the test. Not the ugly integrals and summations and things like that. The mathematics that you better be able to defend or talk about are the different approaches to doing topology optimization. And the little bit of mathematics that is kind of wrapped up in that, in those approaches. Okay. Other questions?
Is it open book and open note?
Yes, it is.
So we could technically just print out all the lectures up, okay?
You won't have time to go through them all.
Yeah,
Whatever you feel comfortable doing or with. again, you're not going to have a lot of time to go flipping through, looking for stuff. You're gonna have to come prepared to take the exam. If you have some extra time, reference your books, reference your notebooks, your lecture notes, things like that. Any other questions? Okay. I believe this is a slide we left off on. Is this correct? Okay. I think, if I remember right, we had just gotten to the point of where this equation popped up, and we basically said this equation inside of the first square brackets represents our first curve. It is multiplied times 1 minus v, which is it's basically a blending function in the v direction. The second square brackets represents our second curve, our second cubic curve. It's multiplied times v, another blending function. These two blending functions happen to be a linear, the combination of them is a linear blend from curve 1 or curve 0 to curve 1. And so we get this nice, pretty green surface as defined by two cubic curves, cubic in U, linear in V. Okay? Does everybody kind of see how this is developing, how it's coming together?
For your subscripts, you got like P0, does that refer, which curve does the first zero refer to, which curve does the second zero refer to?
So this first curve refers to this first one right here. Okay. And so what we need to do, so there's our curve 0 and curve 1, and these P's are the control points of each of these curves. So we have kind of this network. It's no longer a control curve, it's a control net. Okay. And what we need to do is figure out how to put it in our famous matrix equation, similar to what we did for the curve. And so it's pretty easy going from our last equation here. It's pretty easy that we can just take our V's, and break them off, okay, and put them in a matrix form. And this is the matrix form. So if we take this top 1 minus, or minus 1, multiply it times 1 and V, we get our first blending function. We go 0, 1, multiply it times that, we get our V blending function. And so we get a vector. When we combine those two, we get a vector that is 1 minus V and V. We multiply that times this curve and we get the previous thing. So we're just working backwards into a matrix form. But we already know what these C0 and C1 looks like, right? So this is our matrix representation for C0. Our matrix representation for C1 looks very similar. That's from our curve experience. Okay? So we need to somehow take these two things and stick them into here. Okay? And when we do that, it ends up looking something like that. So we take our P's, we first put the first column of our P's is our first curve, our 0 curve. Our second column of P's is our second curve. And when we look at this thing and multiply it all together, we get that surface. If we choose 0 for U and 0 for V, this whole thing collapses down to P00, our first point. Okay? If we choose 1 for U and 1 for V,